Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever thought about how we learn and remember music, especially across different cultures? Well, scientists have created a really cool game to explore just that. This paper introduces something called TuneTwins, which is basically a game designed to help us understand how our brains process music, especially our memory for it. The big question here is, how can we collect really good information about how people understand music from all over the world, not just from a small group of people in one place? They wanted to make research about music cognition more accessible and more fun. Think about how scientists usually collect data. Often it's in a lab with very controlled conditions. But sometimes, real life isn't like a lab, right? And when it comes to music, which is so personal and cultural, a strict lab setting might not tell us the whole story. The researchers here believe that using games is a great way to get lots of people involved. People who are genuinely interested and motivated to play. They specifically looked at auditory matching pairs games, like a sound version of the classic memory game. The whole idea behind this is that if people are having fun playing a game, they're more likely to engage deeply and give us better quality data. They're not just doing it for money or for a grade, they're doing it because they enjoy it. This intrinsic motivation, as they call it, is super important. They're also tackling a big issue in science called the replication crisis, where sometimes studies don't get the same results when other people try to repeat them. They think their game-based approach might help make science more robust and reproducible. The paper talks about how too much control in an experiment might actually be a bad thing sometimes. It's a bit counterintuitive, but they suggest that allowing for some natural variation, like in a real-world listening situation, can actually make the findings more reliable in the long run. And making research available online means people from anywhere can join in, not just people who have easy access to a university lab. They point out that getting people to participate in studies just by offering money can lead to people just clicking randomly to get paid. This doesn't give us good data about their actual thinking platforms. Like Amazon Mechanical Turk have been used a lot, but the researchers worry that the same few people are doing most of the tasks, making the participant pool less diverse and less representative of the general population. The goal with TuneTwins is to make the game itself so interesting that people want to play without needing a big paycheck. A really key part of their approach is making the game intuitive. They want people from any background, any culture, any age to be able to understand it without needing complicated instructions. This is super important because most psychology research is done on people from Western, educated, industrialized, rich, and democratic societies, or weird societies as they're called. We risk seeing the world of music cognition through a very narrow lens if we don't include more diverse perspectives. So, the main goal of this paper is to present their new game, TuneTwins, and show that it can be used to collect good quality data about musical memory from diverse groups of people. They're not trying to solve a specific music puzzle here, but rather to show that their game-making method works. They want to encourage other researchers to use this approach by making the game's technical base open source and easy to adapt. Why did they choose a memory game like TuneTwins? Well, memory is a fundamental part of how we understand music, and it's something that everyone has regardless of how much musical training they've had. The game memory, known by many names like concentration, is already familiar to many people, making it easy to pick up. Music memory is interesting because it can show us what parts of musicality are universal to all humans and what parts are shaped by our culture. For example, we tend to remember music that is familiar to us from our own culture. By studying memory patterns, researchers can learn about this balance between our shared human abilities and our unique cultural experiences. The memory game itself taps into simple desires like problem solving and getting better at something, which are all part of what makes us feel motivated intrinsically, according to self-determination theory. In the classic memory game, you flip over 2 cards to find a match. If they match, you keep them. If not, they go back face down. The goal is to clear the board. They're adapting this for sound. The big difference in the paper is they focused on a solitaire version, where the player is just trying to clear the board as fast as possible, making it a direct measure of their memory skills without the complexities of playing against someone else. Now, what makes TuneTwins different is that instead of cards with pictures, we have sound clips or auditory cards. A pair means 2 sound clips that are supposed to be the same. The really interesting part is that they can create different types of pairs. They're identical pairs, but also pairs where one sound is an original and the other is a slightly changed version of it. This helps them test how well people can recognize music even when it is a bit distorted. They designed a specific way to interact with the game. You click a sound, it plays and the visual cue shows it is active. Then you click a second sound. This second click interrupts the first sound and plays the second. After the second click, you get immediate feedback if it is a match or not. They say this 3-click system helps create a consistent and engaging experience. TuneTwins has a clever scoring system. You get more points for matches you make because you remembered where you heard it before, which they call a memorized match. You get fewer points for a match you make just by luck, which they call a lucky match. This encourages players to really try and use their memory. They also have an analytical score for researchers that counts only true memory matches, separating them from lucky guesses. This dual system is flexible for different research questions. The researchers also got super technical and created a mathematical model of how the game works. This helps them understand all the possible things that can happen on the game board and how the player's actions change the game state. This is important for the simulations they did to figure out the best way to design the game. They ran huge simulations to figure out the best size for the game board. They wanted a board size that was challenging enough to show differences between people who are good at memory and those who aren't, but not so hard that people give up. Too small a board and everyone gets a perfect score, too big and it's frustrating. They landed on an 8-pair board, which is a 4x4 grid. This size they found was good for showing performance differences without causing ceiling effects. Plus, a 4x4 grid looks nice and works well on different screen sizes. This design choice is all about balancing how fun the game is with how useful it is for science. So, did it work? They tested TuneTwins in a few different ways. First, they did a proof of concept experiment with people mostly from Western countries. They used instrumental theme tunes from popular television shows and messed with the sound quality, making it harder to hear the pitch. They thought that if the pitch was degraded, people would have more trouble remembering the tunes in the game. And guess what? It worked. When the pitch information was messed with, people made more mistakes in the game. The harder it was to hear the music, the worse their scores were. This shows that the game is sensitive to changes in how we process sound and memory. They could see real differences in how people played depending on how degraded the music was. This graph shows that clearly the original corpus is the music with no changes. As you go to moderate degradation and then severe degradation, the scores drop significantly. This means the game is picking up on those subtle differences in auditory memory. This graph shows another way they measured performance. It's the number of turns it took to finish a game. The more turns it takes, the harder it was. Again, you see that as the music quality degraded, it took people more turns to complete the game. So, the game is definitely a valid tool for measuring how well we remember sounds. But what about engagement? They also tested the game with different groups of people. They took it to the Mengele Bayaka hunter-gatherer group in the Congo, to kids and adults at a science museum in Amsterdam, and then they launched it globally online. This table is really interesting. Look at the Congo group. A huge 71% of people played more than one game, and 63% played 10 or more games. Some people even asked to play more TuneTwins instead of other planned experiments. This shows the game was not only easy to understand, but also genuinely fun for them. They were able to learn just by watching how others played. Even in the online version, where there was no experimenter to guide them, a good chunk of people played multiple games, and some even went through all the difficulty levels. This really shows that the game itself is intrinsically motivating. So, what does all this mean? The researchers have created a game TuneTwins that is not only fun, but also a really useful tool for understanding how we remember music. It works across different cultures and age groups. And importantly, people actually want to play it. This means they can gather a lot more data from a lot more diverse people than traditional methods might allow. They've shown it can measure how well people process sound. By changing the music, they could see clear differences in the players' scores, proving the game is sensitive. They also admit that other things can affect scores, like individual differences or how well someone learns over time, which is good critical thinking. One of the biggest takeaways is that the game works in different settings, from face-to-face with a researcher to completely online. While online studies might have more people drop off, the fact that so many people kept playing TuneTwins, even through multiple difficulty levels, is a strong sign of its engaging design. This is crucial for citizen science, where you want broad participation. The beauty of TuneTwins is how adaptable it is. Researchers can change the difficulty, use different kinds of music that are relevant to specific cultures or research questions, and adjust how the scoring works. They can even record very detailed information about every click and move a player makes. This allows for really in-depth studies about memory, perception, and even how culture shapes our musical minds. In conclusion, TuneTwins is a promising new way to do music cognition research. By making it a fun, intuitive game, they're opening the door to collecting much richer and more diverse data than ever before. It allows us to explore what's universal in our musical minds and what's shaped by our individual experiences and cultures. This research is a great example of how we can blend science and fun to understand ourselves better. It shows that by making research engaging, we can unlock new insights into how our brains work, especially when it comes to something as complex and universal as music. What I find really exciting about this is the potential for future research. Imagine using TuneTwins to study how children learn musical concepts, or how people who have never had formal music training still have incredibly sophisticated musical abilities. It also opens the door for cross-cultural comparisons, not just on a large scale, but in a way that respects and incorporates the nuances of different musical traditions. It's important to remember, though, that like any study, there are things it can't do. While they've tested it in a few diverse settings, proving its universal appeal requires even more testing in different cultural contexts. And as they mentioned, online studies mean participants are self-selected, so the people who play the most might be different from those who don't. But these are common challenges in collecting large-scale data. And the TuneTwins team has built a strong foundation to overcome them. So, what do you think about using games like TuneTwins for science? Let me know in the comments below. And if you enjoyed this dive into music cognition and game design, please hit that like button and subscribe to RUBIN'S Mind Lab for more brain-bending science. We'll see you next time.